Least squares techniques are centrally focused on creating mathematical models of real-world data. In this video, we study the least squares problem for creating a linear model using a small data set. Assume we collect two data points from an experiment, point 1 and point 2. We find the slope of the line connecting these points and create a model. By design, this is the line of best fit because it exactly replicates our data. Using this model, we can formulate estimates different from our collected data points. If our estimation lies between our collected data points, we call this guess an interpolated point. If our guess lies outside our previous data points, we call this estimation an extrapolated point. What if we collect a third point? How do we model 3 points with a line? One idea is to haphazardly choose point 1 and 2 and create a line. Using this model, we can guess the value of point 3. Notice, our extrapolation does not fit the third point exactly. However, we can quantify the error between our model and the data. A different model arises if we choose point 1 and 3 and create a second line. Using this model, we can guess the value of point 2. Again, the second model does not exactly fit our data. In this case, the largest error in the second model is less than the largest error in the first model. This observation leads naturally to the question, can we create a model of our data that is guaranteed to minimize prediction error? The answer to this question is a resounding yes. In fact, here is that model. Notice, this model does not exactly replicate any of our collected data points. As we did before, we can measure the error between our model and our collected data. Let's compare this error with our previous errors. We see that the individual errors from this third model are smaller than the errors from model 2. Such a model that minimizes total error is called the line of best fit. Finding the line of best fit is one application of least squares techniques. The techniques of least squares are focused on using collected data to create mathematical models. The main idea is to minimize the error between the predictions from our model and the collected data. We end with an overview of the entire process of solving real-world problems using least squares technology.